Right, hello everyone. Welcome back. Is this public, the stream? I hope so. Let me check on Discord if it was announced. Yes. Yes. Okay. Hey, Mr. Hoon. Mr. Hoon. Mr. Who. Henrik, hello. Yeah, public. So I was really tired yesterday. Wasn't very productive the last hours. Especially when stuff is not really functioning properly. And we had some issues. Okay, so short recap what we done so far for people who are watching it maybe offline or just joined. Can I reload? Oh yeah, okay, here we can run that. Oh wait, here we go. So we wrote this IDE and developed an assembly language and an interpreter and a compiler and so on. We can run it, and this is a small display. It's compiled into bytecode, and we have a decompilation as debug to see if it's matching, and you see some labels are converted into actual offsets in the compilation and whatever. And you can also download the binary. This was yesterday's stuff, and then you can also just load it from and run it there. And let me share the Discord channel, and we have someone called it luniASM. Invite never expires. Okay. Here we go. So if you use this link, you will find the channel where you can share your contributions. And I changed also the GitHub. Here you can just download it and run it in the browser. Here, this and Discord. Where is it? Here. Hey TMK. Christian, no worries. Hey Pico Planet. Welcome to the channel, first time chat. This was my example application, and you can get it in the repository. You have basically you run the IDE HTML, which has the example code, and in the documentation you have all the opcodes with description, which is not very great. I have sometimes for the more complicated stuff, which an example and with explanation, which is the best. What is this? Yeah, hardware addresses. This is how we will map everything to an actual physical device, and the actual physical device can be seen here. So this is YouTube. Okay, yeah, sweet. And because of an issue, I had to take off yesterday's stream. It was 6 hours, and it was a little bit dreadful. So not worth rewatching it, especially as we did some maintenance and not so much progress. bit shifting. Even with the code here. No, it's just incrementing the colors and looping XY. That's all happening in the code here. That's just an example for testing, and not all opcodes have been tested properly yet. So, and there is a call for contribution, since you can basically download the binary and drop it in the shared Discord channel. I can take the result and run it here, and we have a challenge. If you manage to implement Game of Life in that, you will get one of the rare version 0.3 prototypes. There are only 3 version 0.3 prototypes yet. So this is a unique challenge. And the thing is, right now we have RGB display here. That it will be like Game of Life if you can make it only like black and white. That would be awesome. Yeah. We have already a contribution. Let's check out the Discord that I will show right now. I need also to record it. So here, let's start recording. And so we have a disk, which is his name is cycling. No, what's the YouTube name? Oh, we have so much stuff going on there. Here. Yeah, Life in Cycling, and on Discord it's disk. And we got a contribution already, and we can just download it here. Let me download it and just load it here. File selection, doxing myself. So let's load this. I have the one here already. Yeah. And here we go. It's not the code. We don't have the disassembly because we got the binary. And this is actually the code. Let me turn off that one. So this is the disassembly, and we have the first code running Rickroll. Hey Deshipo, look at this. You have to hurry up. We have already first contribution here by Life in Cycling, Rickroll with color cycling with the background color. And this is the disassembly for it. There's actually something like actual processing, and there is just some constants pushed in the RAM. So this is really cool. In the theme of the custom ASIC that I did, we have now in luniASM the first Rickroll already. Amazing. Yeah, but there is. Let me load different ones. So this was, we have also this zoomed here. That's zoomed in. That's the second contribution, and now I have to break it because I found a bug. Yeah, that's all we got, I think. Yeah. Unfortunately, I need to break it now, since what did happen? Oh yeah, yeah, I didn't load it properly. So I need to break it because I discovered that the memory indices are wrong for the graphics. We writing a double word, but indexing like bytes, which is wrong. And I discovered it by getting this one running. So this is a test that's just code that writes the first 4 pixels, and it's running. So the interpreter runs on the megaplex already, but I discovered a bug there which had a difference here. The code looked different in that one, and I didn't store the code. Oh well. Let me show it. There is like yeah. So we just incrementing here by 1 the address, and yeah, that needs to be by 4 because RGBA or RGB and 32 bits is 4 bytes. So the address calculation is wrong, and we need to fix this, and this will break. Unfortunately, this will break the nice demo that we got from Cycle in Life. Here, that one here. That will break. So the Rickroll. Oh well. Yeah, better fix it now than later. And there are some improvements that we were thinking about, but I will concentrate on making a demo for that. All right, enough of the recording, and now I will fix the issue that we had. So where is it? IDE here. The problem with the interpreter is that GFX is 32-bit. Where is it? Memory map, and then we have int32 array, which is not so great. We have the access here, parse in and write int. Yeah, we can move the write int somewhere outside, and use it here as well. Or do we? No. You know what? Let's not overcomplicate this here, the interpreter. Oops. Uh-oh. It's in the compiler. Path right int. Oh, I copied it. Okay. Yeah. What did change? Only this. Okay. Let's remove it. Sorry. Yeah, so memory map, yeah, address, this is just wrong. This is just wrong. The heap, everything is 32, but we want to address here we want to address byte arrays. Maybe I should really use this. Let me copy that first. And this should be uint8 array. And this will break everything, huh? Okay, this write int. This heap, and then we'll fix the address, and then v, and this will be numbers 4 bytes. And same with gfx. And this is IO, which is no use for now. And we need, oh yeah, write int, and is there a read int? There's no read int actually. Nope. Yeah. Let's clone that read int. Wait, I can remember I implemented it. No, I didn't. B. Let B 0 B. There is no conversion into integer, like signed integer whatsoever. So v or equals. Hey Caspar. Caspar, was it you who wanted the C++? We need to talk, my friend. Hey, Nekwoza. Plus I. Aha. Is this correct? Yeah, that looks correct. Read int. Yeah, we will find out soon. And we need to this read int. Any heap. I'm fixing a bug right now, and bytes will be 4. Okay. Oh, there is something missing in the read int. Return v. gfx and IO. gfx and IO. IO. Okay. I think this might be it. Now, let me test it. So what we will see is now a broken IDE here. Okay, run it. Oh shit, you ain't Twitch. Ah, you want the jump thingies? Why not loop? JR. What is JR? Jump. Jump relative. Is this jump relative? Okay, and now oh yeah, we have heap, we have this. This is missing. Now, this is broken. This is broken. And also we need to convert differently. So this will be show image data gfxi. I think this must be correct. Hey, Paulus. Okay, you see that? No. Yeah, I will tell you what the issue is. I just need to commit so people are not implementing on the wrong path. Okay, so we have now the problem that we add the address, increment, yeah, we need to increment 4 times. That should run now correctly. Yeah, this is what we want before that. Or we do push 4 and then add run, and that works as well. Okay, this is now fixed version that should also run on this small device here. But let me fix the code here as well. This is sick. Why? Should I? How do I do the Twitch notification stuff? I have no clue. Strange. Okay, so push 4 and then add. Okay, let's clear it and see. Okay, that works. Now let's push it. Fixed. here, commit, boom, sync changes. Go to what? Okay. It's always the same time. I don't know what you're talking about. I deliberately set up the stream on YouTube at 12 o'clock today, so I have no clue why you weren't notified. You need to turn on a Discord notification for the live channel. There it's also listed, at least the YouTube link. Most of the time, sometimes it didn't work. Okay, we can run this example on this device, but we don't have RGB. We can copy to clipboard. Just one click, it was compiled and nice. And then we will paste the code here. Telegram notifications. The 80 for what? How does that work? Okay, so this is the code. Wait, is this the same code? No, almost the same code. Okay, so we have new code. I will just compile it and we will run it. But we need like to convert the RGB values to grayscale. Now programming still is obnoxious with this thing, but at least I fixed how to write the pixels. Now, Caspar, you will see what the issue is. Did it write? I hope it wrote. Here we go. So it's taking the red value, which is 0 in the first column. Okay, it's not that fast. It's not that fast. Go to is just push and jump. Okay. This is basically red is 0 here. So how do we do proper color, add color and mem RGB? We can do something like, no wait, 8 0. Oops, I pressed save. Nah. Control S. Okay, that didn't work. Huh? What happened? Was it 4? Something's broken. Not storing anything. Okay, 4, 8. Huh? Oh, that's the address. Sorry. Here. 8. Here we go. Okay, this is more flickery, and then we need to add basically 8 here and 0 here Okay, that should be more visible on this device. So let's run it here. Okay, Casper, I tell you what was wrong yesterday with that here. So you remember that we had like the new keyword wasn't recognized. There was another issue. Here we go. It runs. It runs. It runs. We need more cycles. So the issue is interpreter globally, like static globally, wasn't initialized. It jumps directly to the main, and there is a C++ class initialization method that comes before the main. And what happens is, if we compile C++ with this configuration, C++ is never initialized correctly here. Hey Chili Willy, I'm doing fine, way better than yesterday after we seeing the emulator running on the small device now. Happened to you too, Negvoza? How did you change the configuration? Maybe you can help me with the configuration. Or is it the vtable? I don't know. There is like this typical CRT or so. Yeah, CRT. Yeah. So how do we configure that? Other project. And I had a different interesting thingy. Oh, let me change this number of cycles that we run per wow, no, why is everything so slow right now? Let me check what takes so much CPU. Shit, my PC is completely stuck. I want class. What is going on? Discord? Oh, anti-malware. OBS Studio, GFX. Yeah, I guess this is the problem. It might be running too fast. Yeah, let's execute it more often. So we have that here. Let's run it 15 times faster. So or we can run it yeah, 16 times. So we execute 16 cycles, and I will show you the strange thing that we get from the compiler. Okay. Yeah, probably. Okay, so that's faster now. Sweet. Okay. Still not real time, but we will get there. Okay? We need to optimize it, but the interpreter works. This is amazing. Peeps, you have to be joyful now. Interpreter runs. Sweet. Okay, and I'm also recording on my hardware. Probably my hard drive is full of shit. Okay. Yeah, so one thing is I moved it here with static, the interpreter, and then, you know what happened then? Boop, boop, boop. Then I had to add... Oh, why is everything so slow? You probably get frame drops here. What is going on? Oh yeah, wait, let me close Twitch here and this one as well. Run debug settings, no, build toolchain. Paths and symbols. No, where is it? It's so obnoxious here. Build. Where are toolchain? No. Symbols. Huh? Tool settings. Yeah, so I had to change the command line and add this here, thread safe. Otherwise it won't be able to. If I compile it like that, it tries to like yeah, the problem is it tries to use like new C++ features for multi-threading, and then you have like a mutex or something, CXA guard acquire. That's probably some kind of mutex or critical section or whatever. But why? How do you know that? I mean, if I wouldn't like read some forums today, then I wouldn't find that thing. So I will never remember that for the next time. I searched for forums when CXA got acquire, and then you had like some people suggesting you use not the GNU 11 C++. So if you remove that, it will work as well, but then you won't be able to use like the latest C++ features. So that might be also a solution, just to not use like the latest C++, because that could be less performant on such small devices. I mean, if you have like critical sections and so on. Threading, yeah. Yeah. Yeah, you will never find this again. And the problem is now we have like this default initialization of the classes and so on, the static classes. There's no way we can do that. So I can show this. I will move the interpreter from here. You know how I found out? So I put it here. It's the same code. It should be initialized. We don't get any errors, but it won't run. Now the show demonstration effect here. Let me program it. I need to be sure that it's programmed. Here you go. Doesn't run. It's not initialized. Nothing happened. This code line never ran. This is even worse. Yeah. Oh. You know how I tested it? I had to debug it. linker script, that's all done by Eclipse here. Some sort of configuration, I have no clue. I will tell you how I found out. I displayed the IP pointer, the instruction pointer on the screen, and it showed nothing, and I was confused. Maybe it's... And then I displayed just code size. Just displaying code size, which is a constant on initialization of this class. It was also 0, so nothing was initialized from the beginning. It was just not running. So terrible. I have crème brûlée today. Yeah. So probably we need some CRT main whatever and configure that somehow. But this is this a project matter, or where to configure that? I hate it. So how do we configure it correctly? This is still struggling. What is taking so much? I think, yeah, we have Discord. It's somehow locking up today. System. Okay. Yeah. Preprocessor includes warnings, miscellaneous. Linker. I have no clue where to set this up. Is this a project setting? Usually in Visual Studio you can set the start routine, and then you have the CRT whatever main. Build settings, I don't know. Oh shit. CRT. What's the name of the CRT main C++? Main CRT startup. Main CRT startup. Eclipse. I don't know. Oh, where's the entry point? Does anyone know where the entry point is configured? Actually, really. What is this? No. Project Explorer. Maybe there is something in the, like a build file or something. Oh wait, that's the wrong project. Here. Should close that. Sources MK. Yeah. Oh yeah, startup. What? Oh, and the other thing. I'm wondering if we, what the problem with new is. Do we need to maybe include something? Oh yeah, execute. Constructor. Check. Okay, so we have undefined reference. So there is something wrong, like the linker setting. Oh wait, isn't that a make file? Yeah, but who creates the make file? What is S? Startup, you mean like the... What is S file? Assembler? Funny. The interrupt handlers are all here. System init. Main. Jump. What? Yeah, but the makefile is generated. So maybe, what is the name? Main CRT start up here. And why the new isn't resolved. So let's skip that for now. Where's we have the definition, but not the shit, now we need to change that again. Okay. Yeah, that was. That will be interesting. Nope. Main CRT startup doesn't exist. Shit. No, not using new anymore. Like Vorza, your conclusion is that startup is for C code. Some section need to be copied. And parameterless construction. Yeah. But when we want to add the transmission later, oh, you mean like we should just make the class and then, yeah, let's do that. Okay. But I need like properly working C++ here. Why is it such a difficulty to do that? Huh? What? Clear BSS section. Oh, so this startup is completely unsuitable for C++. Okay. Ah, shit. Yeah, then let's leave it and do a constructor, an init here, interpreter. Void set load. Wait, that's a... No. We init this now. Init, and then let's do but this won't work. This is like probably a stack. Let's put it here again, but I tell you, it doesn't look good. Okay. Init. Let's do it. That has the disadvantage we didn't clear the memory, but oh well, let's see if that will run without the static stuff. It compiles at least. Yeah, okay, that works. World is cruel, yes. All right. Now, what do we do? Game of life? We need a better conversion to graphics and faster code, faster execution, and so on. Oh, and we need to remove the delay here, probably. It won't have ghosting, though. And then we might want to implement grayscale. It's a little bit faster, but not much faster. Can we run it like that? It will flicker now. Get ready to flickering. Wait, we can refresh the frame buffer each 16. Here we go. So we will run it even 16 times faster than that. Then shit, I hope I didn't break the stream. Sorry. push the wrong button. Might have buffered. Okay, here we go. Yeah, that's fast enough. That's fast enough. Now let's implement game of life. Okay, the update is... Hey, Rohan. Yeah, it's the 20-cent risk, not the 10-cent risk. We can defocus a little bit if we aim like then. Here we go. Okay, we need some proper code. Okay, maybe I want a little bit better performance now. We don't have grayscale yet, but for game of life, this should be... No, let's do game of life, okay? Game of life here. Yeah, this is the code that we had now. Stop. Let's do game of life. Yeah. Okay. Everything clear, clean slate. Let's start. I forgot my language. Push. Let's do 16 by 16. 16 by 16. Hey Max. Or you know what? Nah, I was addicted 20 years, no, 30 years, no, 25 years ago to low level programming, but now not anymore. Okay, we need like a game of life. What is a good starting thing for game of life? Good, so people. Beehive. Boat, tub, aircraft carrier. What? Ah, shit. Game of life. Let's find. Yeah. Game of life. Okay, this is a starting point. Yeah, do we have like a new one? No, I want a different one. No. "40 years ago, I was there. No, I had nothing to do with computers back then. I was 4, almost 5. We can drop the documentation and it will do it for us. So what is a good beehive? Okay, let's try that. Oops. Start. Huh? Still lives. Oh, that's still lives. Okay, oscillators, tolls, spaceships, lightweight spaceships. Okay, what is this? I want something that emits, like generators, glider gun. Infinite grow. Okay, we have this one here. Okay, so we have let's remove that. Clear. Can we clear? Clear. Okay. What is the aircraft carrier? Aircraft carrier is okay. Clear. Automata, oscillators. Glider. This one looks simple. It has some simple rules. Oh yeah, I like that one. Or do we start with that one? That one also looks easy. That might be a little bit big. Clear, let's start that. And at some point we will use the buttons, but I need a video this weekend to earn money. Here we go. So, basically, you have the rules that neighboring cells. Where are the rules? It's like Game of Life. If there are too many neighbors, the cell will die. If there are just good amount of neighbors, it will. Yeah, I hope this or is this. Oh, that might destruct itself if we wrap around. That's a huge glider. Yeah, that's. Okay, let's take that one here. Yeah. Reset. Okay, here. This is what happens. One neighbor, it dies. Too many neighbors, it dies. 4 or more neighbors. And then 2 or 3 neighbors survives, and yeah, empty space with 3 or more gets populated. So these are the rules. And everything after that happens by itself. So very simple Game of Life. Yeah, well, let's try first filling the screen, and then we will run it in screen space, maybe. Push, let's say XFF push A00. We will initialize it like that. And then store. Wait, where is my thing that I wanted to run? So let's draw it. Let's draw it. Okay, init. We have that. We have that. Then we have. Huh? The clock started at what? 8C16. Let's run it. Yeah, it looks fine. Then we'll do what is where is this? Where's this? That's too far. That's too far. 4 0. That's the one. Yeah. 4 0. Then we have. You know what? We could clone it, but oh well. 4 8 8C. Then we have 8 no 8C 8 9. Okay, 2 more rows, and we have the initial point of our endless generator. Google Sheets to create your. You can probably use it anywhere from any tool. I would really love to make a plugin for Visual Studio Code with this whole IDE thingy. Like just replace the editor by something like. But I don't know if you can do for code, if you can do like buttons or whatever. I don't really like the lower like tool banner or what it is. 9 9, and then we have that's 8. Then we have 1 4. The best part is you can just one click, it's instantly executed. It's fast AF. Boop. And then what was that? Yeah. One more row and we are done. That's that's I don't know, I don't have small glider. If you have like a really small glider, you can give it to me. This is like this endless generator. We got this one here, like infinite. I think that was that. Don't distract me. Okay, 2 more. That's the starting point. So we have 8. Here. Now, wait, is this a rat? Start, push, start, push, init, jump. Never tried this before. Nope. Huh? What happened? That should work. This is the return address. This return address. This is the jump. What did happen? What did happen? Push, push. Yes, I did. That's super easy. We have the code here. It's correct, but something is off. I think the stack jump and jump store B and jump. Huh? That should work. What is the issue? What's OP? Undefined. What's the instruction pointer? Not a number. The instruction pointer is not a number. Probably my stack ran empty. Let's check. Uh, 11. Oh, okay, I got the problem. It's my code, not the debug, no, not the interpreter. Oops. Ah. Oh. Yeah, we expect the return value. We put it here, but we also after start we run into this method, and it doesn't have anything on the stack anymore. So we need jump, push, start, and then jump. Otherwise, this is our loop. Okay, so let's loop, push, loop. Loop, but we could also, init is good enough. init game. So we can init game here. I will use main loop, or let's call it just main, because loop is a keyword at some point. Main, push, main. Okay, run. It runs. No, wait, no, it doesn't run. What? Oh yeah. Okay, that runs. Nice, and it's stuck here somewhere in the main. Now we need to we have jump. I tested this the first time, but Life in Cycling already did that before. So now we want to test the neighboring pixels. So we do a for loop, which means we push, what do we have? It's 16 by 15, but we just do 256. We don't even need that. Pixel loop here, and then deck clone jump not 0. Oh wait, push pixel loop. Okay, and this is basically our loop counter, and we can test the loop counter by reading it. So we push pixel loop main. Oh, we also need to store push a. Yeah, I will just not show the last pixel. Okay, now we can do a strange thing. We can do a strange thing. Jumps not 0. Here pop, that needs to pop the address. Pop the counter and pop the address. Okay, this is now a consistent thing. Now I want to test something that I never tried before. That would be loads. So push 1, then loads, or no, we need push. We just write, let's say, what is pink? What is pink? I don't know what pink is. I do some value. Okay, so this is the color. This will be the stack offset. Then loads. We have local variables now. That's the address. Load address. Then we can do store. So this loads the address. And this should basically replace the first pixel. No, it doesn't do anything. Shit. Where's my bug? Oh, is it 2? No. Push A, push. So this is 0, then it's 1, then it's 2. Then it should load from the stack. And then it should store. This pixel should be replaced. Thanks, Rohan. Bye bye. Nobody used loads before. We can check what happens. We can check what happens. Maybe I will fix that if there is loads. Regal Blue. Run. Okay, what does the stack say? We have color 0. So let's check the stack now. This is 0. Oh, okay. There's a bug. Okay, found a bug. It doesn't load the right address. Ah, shit. Wait. -1 is not 0. It's not stack top. So we need to decrement by 1. This still might work in loads. -1. Here we go. -1 is the top of the stack, and then we have. Okay, run it. Yes, we got it. That doesn't look like blue. It's probably reversed. Anyways, it does the job. Loads works now. I need to commit that because that's crucial. Loads fixed. And that might be might be misunderstood. Loads of stuff was fixed. Okay, so this is fixed, but we should loads. Then we don't want to store. We want to clone. We want to dudes, that's easy. We add 4, no, we clone. We push 4, we add, we store, we push. It's 3 now. No, is it 4? Well, how does the stack look like? We have the incremented address. We have the address. We have the pixel color. We have the counter, and we have the the old address. So it's 0, 1, 2, 3, 4. So we push 4, we stores, and then we store. Okay. Oh no, that doesn't work. Uh-oh. Okay. We need to check that one here. Run. Is this broken? Or is it just stuck? Wait. Was it just stuck? No. Huh? Where's my interpreter? Here. Stores. Okay. Paused on breakpoint. Okay. So 10, 10. What is our 4? That's the offset. That's the value. And we have on the stack this. Okay, this is the old one. The color. So the 0, 1, 2. It's 3. 0, 1, 2, 3, not 4. Okay, that was the mistake. It's hard. Okay, so we push 3. There is documentation for all this stuff. Oh no, I don't want to save. Okay, here we go. Run it. Okay, it's overwritten. Okay, let me comment the code so you're not confused. Load address. Copy address. Inc by 4 for next pixel. Store back to stack offset 3. Load address offset 2, and here this is frame address used with loads and stores. Okay, so this is like a local variable. Local var. That's an example how to use local variables on the stack. It's complicated, a lot of code, but it works, and it works with this address here. Now we don't want to overwrite it for now, so we wouldn't do that. I would just pop. Okay, yeah, keep that clean. And now we need to calculate what happens there. We need to take the neighboring pixels. How many neighboring pixels do we take in the game of life? All neighboring pixels? Like all 9 neighboring pixels? No. Or just the just the immediate neighbors? Eight neighboring, oh yeah. 8 neighboring pixels, really? Oh, that's a lot of code then. Yes, okay. All right, so let's calculate it. Oh, that's hard without registers. Yeah, no, I want to use a loop. Yeah, a living QR code. So, we should push a 0 here. Push a 0 here. Then we don't need the color. Okay, that's the count. Yeah. Shit. Nah, I will do fine here. So we have, we just need, I just need to concentrate. Count. Okay, neighbor count. We should not increment it here. We should not do that here. Add, push, restores. We don't do that here. What I will do now is load the address. Now we decrement the address. Since we know the screen's size is here, we can how do I calculate it? Okay, I load the stack offset. No, I load the address. Yeah, I can't work like that, peeps. Push. So we need 16 times 4, 64, minus 64, or 64, and then even one more, 68. So we not decrement, we sub. So this is the address. Let's load address here. So we have this pixel is, or let's say this pixel is the current address. Now we have 16 pixel across, but it's 4 byte per pixel. So if we subtract 64, we end up here. And if we subtract 68, we end up here. This is the starting pixel. Yeah. So now I need to load from there and check if it's we can do a subroutine here. You should look up Game of Life online. Oh, do I? Really? Shit. That's not good. Okay, let's do this then a different way, but we'll be all right. We'll be all right. Yeah, another flight this time. Okay, less talking. We can use. Yeah, we will use the RAM for that. We have RAM. Okay. Ink. Oh shit, and we need a display method and so on. Oh no. Yeah, that's not good. Oh no. Now you started something. Okay, let's do it. Push pixel loop. Pop. Okay, let's do display or show. We need show. Copy to copy buffer and show, and we will write this to 0. Yeah, nah. I will do it like that. I will write it to RAM and then do a nice thing here. Okay, 256. We have so this is initialized now into memory, and then we will just copy the buffer. Wait, neighbor count. We need to remove everything here because I'm not working on that right now and I will forget what it does. Okay, that should still run, I guess. Show buffer run. Yeah, it doesn't show anything. So now we will copy the buffer, which will be basically also that. Copy buffer, which is that's another, oh, that's a new label here. Loop, okay. Push, and then we have deck clone. Okay, copy loop. It's a lot of code for a simple loop. I might want to do like a loop instruction that basically does all what this does here. No, yeah, all that in one instruction, and that's called loop, like in, and then copy loop, push, gift. What is a gift? Huh? We have gifts? What is gift? Oh, thank you for subscription. Nice. A gift subscription. What? Huh? How does that work? Oh, nice. Thank you. I do actually. Okay, so we might need an address. Copy buffer. Oh, we can do a shift. So we copy that. We can do that's counting down from 256. What we can do is like clone it, the 256 from the stack, then push to, oh no, decrement it, dec, clone, no, decrement, push to, shl, we will never see that. Okay, we expand this, then we clone it, we push oh wait, 256. Oh no, wait. We have, yeah, 4. That's the size. Push that. Add. Load. Store, and that's it. That's a copy loop. That copies the buffer from this offset, like the 256 times 4. Yeah, that should work. That's a copy buffer. Does it crash? It doesn't crash, so. Okay, and now we need to take this and display it. So the show will be basically the same like this here. Push 256, pop. That's like the main here. Show. So we have that address. we don't need. Oh, it's a color basically. So we use X, F, 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 F. You can give me pink if you want. Color. Stack offset, yeah. Load address. No. Clone. Push for add. Push. What was it before? We had 3 stores. Hey Adam. Yeah, they're watching me concentrate making game of life here. Stores. Push. No, store. Store, that fills the screen. That fills the screen. Okay, so that just fills the screen with white. And that's pop. Okay, so show jump main. Okay, run. Oops, that breaks. Label already defined. Oh, we have. Oh, yeah. Show loop. That's interesting. This is the first time I see my error messages. Unknown opcode. Yeah. What is in line 58? We have broken something. Unknown opcode store. Oh yeah. Here, store. That's yeah, okay, that works. Fills the screen. This is the first like screen loop with local variables, so you can run it in a function, basically the show function. Buffer, let's call it show buffer, and we can move it. It's now a function, and also that's just a jump, and this is also just a jump, and we put everything here, push pixel loop, and do that. So what we do now is push after copy, push, that's the return address, after copy, and then push copy buffer. Yeah, we should do like something like call, and it will be replacing with that here. jump. And now copy buffer and then show buffer. That's the after show after show body. Okay, now the issue is we just draw now something, and the show buffer should be checking what's in the address there. So we can do load address, that's the target, clone, okay, whoop. Stores that increments and then stores. No, we want to clone now. Clone the address. Clone address. And then we want to push. Yeah. Yeah. 3FF. And yeah, clone GFX address and then change to buffer in load, and then we have the following. We have loaded it, then we push the address, which is non-zero pixel set and then we have pixel set. Otherwise we want to change it, so jump not zero and now we need to modify load 0 load, and what is the offset now? What is the offset of this color here? Damn, I don't know. We have the cloned, no, we don't have the cloned address anymore. We have the target address the color, target address, the color, the loaded pixel, we compared it. Oh, we have 0. No, it's 1. Load. Stores. Okay, if we don't call copy buffer, that should display our game of life again. But I have no clue if that happens. Nope. It even dies. What happens here? Wait. Clear that. Ah, come on. How do I clear? Yes, it is. What is that? Where does it die? Undefined. Ah, shit. I messed up the stack. Extra characters. $79. I have no clue which line it is. What is line 79? Extra characters? Oh, yeah, push. That's the issue. That's push, not load. What did I do? There is no. Okay, now. Okay. Syntax error. It loads. Peeps, it loads. And we can do like push 1 just here. It loads and we have double buffer. We have double buffers. We don't need FF here because we just check for non-zero. Okay, here we go. Still runs, yeah. Okay, and then if we run copy, it will be overwritten, the initial state. That's why. That should be empty. Uh-oh. Copy buffer doesn't work properly. Yeah, copy buffer doesn't work properly. Let's check that. Okay, copy loop clone. That's decrement store. Voila. The editor is strange. Clone. Clone loop counter. Decremented. Push. Shift left. Never tested shift left before. Then clone. Then push. decrement, push to shift left. Stack is basically target address counter. Push one, what? We are shifting we multiplying by 4. Target address counter, clone. Then we have stack will be, wait, clone, push, add. So it clones the target address, source address, adds. So stack source address target address counter, okay. Then we have, oh, let's leave it open because we don't know what's on the stack there. Then we load, that will be, stack will be looking like that. We have value, target, address counter. Oh yeah, that's why it doesn't work. We need the target address here and not there. So yeah, nope. So we need some workaround. And this will be push one, loads, store, pop, deck. Here we go. So this will be, maybe that's more understandable how that works. If you have target, address, value, target, counter, okay, and then you store it. So after that you have a counter and then counter. It's a nice riddle. Yeah, it's overwritten now. Okay, next is to read the buffer. We can even take like easy. We don't even need that here. We can calculate the address because we are reading from yeah, we can do the same as here. So clone deck2 push blah 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 Mr. Freeman stack. Okay. So we can do that. Stack offset blah 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 load address. We don't need that. We just clone the loop counter stack, and this is just source address. Source address and then counter. One hour and counting. Yeah, we almost there. We are almost there. When I have this game of life running, we can move it to there and I have a video for this week. Still have to work through all weekend to make it to like an edit. Okay. Now we need to check if it's anything. So source address, now we need to maybe load it. I could clone this, so we have clone it and then we can add push random seed. I think we will use the buttons in the end, so you can edit it yourself and let it run with the buttons and so on. We can expand this later. Random seed, you need to write a random number generator and I will take it. Add, and then we have stack. This is now stupid because we have now the target address and the source address swapped. Shoot. Unless, no. Clone source address. Yeah. We will do this later. We just clone it for now. We clone it. Hello Holden. We clone the address and we have the source address and the source address. We will solve this a different way at some point. Now we will load and then do basically what we did here as well. The show buffer. That's basically load, push, pixel set. Stores. Yeah, I will solve it this different way this time. This time around. I will load it. So we have. Let's play around and find the best way to make it. So value source counter. Then we can compare. We can compare, so jump not 0. Jump not 0. is here. That's basically cell lives and this is basically cell skip cell lives or cell lives and yeah, we need to push cell lives and then jump. Okay, so this is the else case. No, this is if it lives. So jump not 0. Then we have after that we have here source we still need to change the source though. Push x4 add and we need a swap. Somehow the swap might be good on the to-do list. Do we want to add a swap? The best thing about making a programming language is that you can always do new commands here. Swap store slow jump swap what it does is this push A no B this push no wait A B. So the next pop will be B, not A. Okay, this is a swap. Swap. Yeah. That's a swap. We need to... that's so easy. Done. And I need to implement it in here. So interpreter store loads jump oh documentation oh no okay so we do hey live, I showed your accomplishments and we progressing here. We progressing. A B swap will be nice, and we have some started implementing game of life, which is quite a lot of code, but oh well. here. Push B. Okay, and then doc needs to be done. It's not synced yet, so oh no! Swaps the two top stack values. Okay. Swap doc. Here we go. Swap is implemented now. But before we do the swap, let's do. Should we also do the loop? The loop to skip all that. Okay, loop will be extension will be later. Let me, before I do the swap, this is now target value, no, target and then counter. Then I need to do the following: push 0 where am I? Oh yeah. Push 0. Yes, that would be nice, preprocessors. But I would rather do a plugin that runs like a filter or something that generates new microcode. Stores. Push that, and then we need to. That's the target address. Then we do that. Then we do push 1 loads target 0 target counter. Here we go. Push 0 target counter. Then we do store and pop. Store and pop. This will be target counter. Why did you lose track? I even show you the current stack thing here. Pop, and now we need the same thing on the other side. So this is basically also the same, but in the else case. This is like a big if. And this basically does a 1 instead. And there is no jump. Okay. So if else. Okay, that works. So what it does now is this is I will do a paint MS Paint thing. MS Paint thing for you. Okay, Right now, what we do is we have one memory frame, second memory frame, and then we have GFX here. So this is graphics, graphics, and then we have this is our current state that's initialized at the beginning, game of life. What we do right now is we have the beginning function right now is currently only doing is checking one pixel and writing to the target. So this is like the new buffer. And then we have after that we have copy the buffer. We just copy the complete buffer. We don't do any comparisons, whatever. We just copy the buffer to this here again. And then show is basically drawing this buffer to this here. This is what's happening right now. And then we can just rinse and repeat. So this is not like very performant. We could just like swap indices or whatever. But yeah, I'm lazy. That's why we're just copying the complete buffer and then drawing the graphics. That's what's happening right now. The issue is we don't do any computation whatsoever right now. So what we could do now is we could just let it move across the screen. How about that? We can move scroll the screen. Do you think that will work? That will be the first scroller ever. This long cable here. But I need something. I will take a short break. Now let it move for a second. Okay. So what we can do right now is we can change the target. Change the target. So we clone source, counter load source value. When do we change the source? Oh yeah, we can try the swap. Should we? Yeah, stack oriented. Yeah, okay. We can try swap now. This is basically our implementation of swap here. Wait. So target, we push that. No, store. Yeah, this is swap. Swap. Okay, let's see if it runs. Seems to do something and saves out swap. So let's show it. Let's target 0 and then counter. Maybe show it here. Oh. Isn't that cool? The swap simplifies a lot of things, and I think we have another target. This is another swap. So target address, we don't load this. Why does it jump? We have value counter, okay, store, and we don't have anything anymore. That saved us a little bit of time. Does it run still? Yes. Okay, still runs. Nice. We can simplify code somewhere here. The target, no, wait, if, yeah, we can simplify code here. So we clone it, source, and then we do that here. So we don't have copy code. Source, and then swap, and then we will have target. Yeah, but that also, if I copy it, then I copy it the right way. It's all right. Add, then we have the target. We swap the target, and then we load, which is that target, and then we don't need anything anymore. We just swap target, and it's the same here. We just push one. Look at that, isn't that beautiful? Just push one, swap, then we have target one, whatever, no pop, store, not loads. Wait, swap, target one counter, X. Here, no loads needed. Oh, that's so beautiful. That's so beautiful. We just push and swap and be good. Codes shrank now. Does it run? Yeah, it runs. Nice. More object-oriented features here. Okay, so why refactoring? Because now I have only one place where I calculate, before the if, I calculate the target address. And the target address, we can just push for sub push x3ff and now we have a scroller, a horizontal scroller. No, it's not a horizontal scroller, but no, it will scroll somewhere. I don't know where it will scroll. It's to scroll off screen, and we will see. It scrolls. It will show up at the bottom again. No, it doesn't. Oh, what? Why? Why doesn't it show again? Uh-oh. Oh yes. Oh no. Ah. Okay, yeah. The problem is that huh? Why did it halt? 1FF. Why doesn't that doesn't show at all? Is it completely clipped? What? Huh? We can scroll. We have 1664. Okay, let's do some logic operations here. We push that. Wait. Wait. This is at, that's this target. Now, let's sub. I want a clone, and then I want push. The row is kept, so I do x and what's 64, which can we do? Yeah, I think I did that. Wait. 3, 1, 2, 2, 1, 2, 3. No, I don't have to do that. So this is our we have 64. Yeah. Push and clone, push and then swap, push, sub, push, yeah, 63, and or push add. Now it runs. Now we have a normal horizontal scroller, and anyone who you can find out, I have to get something more interesting, some tea, and you will try to decode what's happening there. Okay. You know what? Ah, here he goes. Caspar analyzed it, masked 16 times 4 bytes of RGB, then got index of pixel in line masking least 6 bit and do the sub, then by or we add address on the or and we add, yeah, that's what's happening. All right. You know what? Why don't we try running it on that device? Okay, let's do again. I'm recording. Why don't we try this intermediate step on the device? I will just copy to clipboard, then drop it there. Swap is implemented. We extended we just dropped a new code here. Here we go. And then we will see if something happens, and then we can continue with Game of Life. Okay, build process. Now let's program it. If this works, I eat my head. Is it only a German saying? I don't know. Yeah, no. That doesn't work. Interesting. Okay, we will debug it later. Almost. You know what? I'm wondering if we have even enough memory there for that. Heap size. Yeah. That's not happening. Heap size must be this here. Okay. Let's see if it even compiles, because we don't have a lot of RAM there. Oh, it worked. Woo! Here we go. Oh no. Didn't work. The upload. No. I think it didn't work. Let me do again. Nah, it still doesn't work. So I might want to debug a few things. Wait, it's a little bit unfortunate that it's... where is my uploader? Okay, here we go. Make sure that I upload it correctly. Yeah, no, it uploaded. Okay. Let's take care of that later. No, it's not that fast. It should be way slower. It's very slow. No. No. That's way slower. Way slower. Something is flickering, but I think there might be like some instruction wrong or something, because it's like the code is not like completely equal. So yeah. Let's take care of our Game of Life first. So what do we want to do? We want to have a function okay, I don't need that here, blah 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 blah, clone whatever, push add. Okay, we are back at progress more. I want to write a function that takes parameters, loads and just, I don't know if it's too much work to do that. Just an offset to the address. Okay. After copy, after show, jump main. Okay, that's the function. Oop. Function inc if no inc if set, and it will let's comment stack will be return, then we have the offset, the address, and the count. No, the yeah. Okay, and the return is basically afterwards. No, that's basically it. Pop address. Okay, yeah, let's do that. So, if set, then increment that. So we will replace basically this part, but we can just clone it. So we need like basically value load, value target counter, push neighbor count. That's the neighbor count. Okay, let me grab my tea. Where's my tea? I forgot my tea. All right, I have some tea. Okay. So this is what happens when we load. We have the source, clone. Wait, yeah, this is not, there is the loop counter source. If we push that, so what we want at the end is address and account. Source. No, wait, this is source. Let's do that. Source. Source inc if set. Or we do it in place. So if we need here a push one loads because we have the neighbor count here, so that's not a loop counter anymore. Neighbor. Nope. Here. Neighbor. And there is a counter. That's the target address. Clone target swap. Do we want to store the target address here? I'm just thinking about the best way of arranging the stack here. Where to put the target without recalculating it. Yeah. At this point, it might just be wise to recalculate it. Shit. Cell lives. Ah, yeah. We can remove that. That's basically a pop. Neighbor count. But what I want to do is I want to get a simpler way. We pushed around the stuff, but now I just want to recalculate. I think I don't know. Source counter. Yeah. Let's leave it like that. Neighbor, and this is source, red source neighbor. But I think I will not use that. I will not use that. Will I? No, I can use it because I can do there an if, and I don't need so many ifs here. So we have neighbor target, neighbor value swap. Okay, here is where we start. Start counting neighbors, and this will be basically not this address. We need to push what was it, 68 deck push X3FF, and then so we will wrap around everything. Boundaries, okay, and then is push upper left boundaries, and then we need to do, we have now the source target neighbor, source target neighbor. Okay, and then we will do push, let's say pixel 0, pix 0, push pix 0, push we need to add inc if set jump. Okay, So we have now the return address, the boundary. So this is just first pixel, pixel 0. And what we do is we have to clone it here, the source, because we want to return basically not change the stack here. Inc if set pix, and then we don't have the load anymore. We just loads 0, 1, loads 1, push 1, and then push cell lives, and then here. Okay. This will do the following. Neighbor and target counter, but we also want to remove the source. We have still this, oh, that's wrong here. So the current stack will be still this stack here. Source, target, neighbor. So first we need to pop it. Pop the source, target, neighbor, loads. We have the counter. Target. Yeah. Jump not 0. Push 1. Okay. Nekvosa, what do you mean? What? No. No, it's 4 bytes in memory. It's 4 bytes. I changed this since yesterday because we always write 32 bits, and there is no way in writing like individual bytes for now. Okay. What we need to take care about is this here. So we have the return address. So we push 1 loads. Then we have, this is our stack then, source, and then we will load it, and then push active cell, not 0, and then we will have here active cell, oh wait, jump 0 is basically not active, inactive, otherwise. Okay, so this is the source is cleared, so loads, no, load is missing. Then we have value source. No, we don't have a source anymore. Then we have push inactive cell, inactive cell. If jump 0, then oh wait, we can return. No, value needs to be shit. Oh, this is evil. I can swap and I don't need the label anymore because then it will just return. Nah, okay. No, let's not do that. Let's not go there. Jump 0, and this is basically value is gone. And we have return that will be basically jump. And here we need push. In that case, we have still red. That's 1, 2, 3. 3 loads. Ink push 3 stores. No. In that case, it's it's 3, I believe, and then jump. Does stores? Yeah, it clears first. Yeah, stores clears first. Yeah, it clears first before it does the stack. Okay, yeah, that increments, and we save a lot of stuff here to that cell. Okay, that should already run. No, it doesn't. Shit. Oh no. Oh no. It doesn't do it. Let me check if we even... if we even clear that. Uh-oh. Does it... Oh, wait. Doesn't take the neighbor count. It doesn't get there. We need debug operators. Uh-oh, 2 hours? No. Okay, let me... I even start counting neighbors. Okay. Let's check. Neighbor count. Clone loop counter. Swap source. Okay. Cell lives. Okay. We have neighbor. Hey Casper, I tried my code and it doesn't run. Now I need to reduce everything here to find out what's happening. Load, maybe load and then nope. Didn't. Yeah. This tea is boring. Oh no, how do we debug that? Shoot. Okay. Pop. Let's run debug mode. It's already implemented. Here. Yeah, but it didn't work, so remembering stack contents didn't work. Okay, this was running for quite some time. What? Let's scroll all the way back. Here we go. That was loading. Decrement push B, that's 20. Decrement push B, that's shift left, clone, push, add, swap. Okay, let's see. We shifted, cloned it. Then we have source, push, add, Nice. And swap, that works. So this is the state here. Push B 68. Oh, that's a sub. Shit. Not a decrement. Okay. Let me disable debug mode. Yeah, okay. That worked. It's probably, does it lose any content? No, it doesn't lose any content. Okay. That works. TMKD. Kogo 100. Well. Okay, now that actually counts the neighbor, so this one works. And now we want to compare. So this is the loads and this is neighbors. Then we have if this number is greater than okay, non-zero first. Let's leave it like that. And most reattached Tetris that I've seen. Okay, we have a count already. Now we need to do pixel 1, which will be basically push for at, that's the target address, and then check for boundaries, jump pix 1. Okay, here we go. Boundaries, pick 1. Then we need to do this once again. Animated QR codes. Yeah. We are getting there. More weird Tetris than that. Yeah, okay. So now pixel 4, which will be basically, we want to go 64 minus 8, that will be 56. That will be pixel 3. And then we do another one, which is 8. That will be, oh, wait. Copy paste error. 4. And then we also add, so we add 64, that's another 56. 56 pix 5. And then we can start comparing against against the values here. This is 5, 6, 7. Okay. That should be the sum of the neighboring pixels. And now we need to compare it. Does it even run? Yeah. It grows. It grows. Yes. That's what happens if any of the neighbors is right now bigger than, and that's how it grows. That's cool. Okay. But it gets slower and slower. Nice. Okay. Next step is, let's look at it again. Yeah, it grows. Next step is to compare with the actual values. What has to happen there? So what do we have? Game of life. When does it live? One or no neighbors, it dies by solitude. 4 or more neighbors, so let me check. We need to okay. Game is zero, 1, and then we have overpopulation, 4 or more. So we have 4, 5, 6, 7, 8 is death. Death, and this is basically 2 and 3. That's the 2 cases. Is there a simple way to make that, compare that? So if we end we need to compare it, end and compare. Or do we just jump 0? XOR? Oh wait. Oh yeah, you're right. There is a difference. So if there is 2 neighbors, it stays the same. So we shit. Oh, this is Oh no. Okay. We have spawn, keep, die. Yeah, so I need to load the actual address now. Hey, Aaron. Oh, Aaron wrote ages ago. I just saw that it was you. Other that. Keep. Yeah, the problem is that we... wait, we copy. We just don't change anything because it's not the double buffer. We have a copy buffer. We can skip and spawn on 3. Okay, let's do that. Let's make a simple case here. Then keep so 3 is always positive. Let's do the following. We have now the address on stack still, but we need to decrement it by 64. Okay, center cell. No, we don't do anything with the center cell, but we spawn it. Keep is basically, we can ignore keep. 3. Because it's, if we spawn or not, it doesn't matter. So let's compare pop the address. Is it? Yeah. We are almost there though. This is I will probably just kill that. We will do the case. So we have the case push yeah. push to push. If it's a 2, then we basically write it. Stack neighbor, that is push to push. No, if it's spawn, if it's 3, spawn, push spawn, jump equal. Then we don't need the value anymore. We spawn in any case. Then we have if keep is basically but we would need to clone it here. You know what? We do it again. We just loads it again here. Spawn and then compare it and then just keep. Jump equal, that's basically 2, keep. Keep and then we have die. Die. Die and then this is basically yeah, whatever. This is die, yeah. Okay. This is die. Case end. Case end. Case end. Case end. Okay, so this is writing it, and here there's neighbor still. Let's keep that here. Okay. This is die, case end. Now we have basically if we keep it case end, nothing happens. And otherwise we spawn it. Where's case end? Yeah, here. What is this? Spawn. Push, swap, store, case end. Okay. That's it. Have neighbors spawn push one loads if to keep and then else die. Okay, jump equal, never tested before. Let's run it. Nothing. Shit. Oh, there is no keep. Keep the frame before. On the first frame there is no keep. Shit. So we need to... We might want to... shoot. But I don't believe that's the issue here. On the first frame there is no keep, we need to copy it to the buffer. So we need to load it actually. Do we have contributions here? Oh yeah, that's the new contributions. We will try them soon. Okay. Let me do push. Let's load it. Let's load the source. Let's load the source. We need to 64 is this one. -8, that's 56. Sub, not deck. Sub. And then loads. No, load. Then we have two because we have so what happens first is keep push spawn. Now we have neighbor or center. So neighbor then will be neighbor center can make the stack here. Stack load center target neighbor counter. Okay, so we have this neighbor load push loads, yeah, then we do the spawn. So if we target, so this is target, We have still the center. Target. That's spawn. So we pop that with keep. Spawn. We need also that case and this will be basically keep and in keep we just do that case and here we pop the center and run. It did something. It seems it's the wrong rules. Huh? Oh no, it's so hard. We have a mistake there somewhere. Something is off. Hey, sick. Welcome. Initial setup and center of screen. So we need we need to add, what is it? A line is 16 times 4, that's 8. Thanks. Yeah. Let's do a new. No, is it? I don't think so. Okay, let's initialize a new game. New game and try basically a different setup. I developed. Okay, let's use a glider then. What's the initial setup here? Okay, this is a glider. Let's use the glider. So I developed an assembly language, an interpreter, and development environment to run stuff on this emulator. And now we are developing in the new language the game of life. So let's start new game of life, which will be the glider should be where is the stable one? We might. Yeah, this is my day job. It feels like a day and night job, the YouTube thing. 4.8. 40. Hey Dave, how are you doing today? Do you want to see progress? Or this glider is way easier than our initial setup. Okay. So let's run it. Yeah, the glider doesn't even show. Ulu ulu, heyo! What we're looking at, yeah. That's as new assembly language, luniASM. That's made for as an emulator to run also on that. Yeah, ChatGPT is not aware of my language yet. We need to train it. Life in cycling did it probably. Here, living in the future. Yeah, the problem is it convergates towards like a CISC design at the end with many exceptions and stuff like that. Yeah, I have documentation. It's here, but it's not very well documented. If it can make sense out of that, then all right, yes. Oh shit, and now I'm stuck a little bit. Yeah. Oh, everyone is joining now. What is going on? It's 11 o'clock. Hour. Yes, no. Something is broken in different hex space. Oh. What is the different hex space? So it No, I didn't. I try. I'm now blasted with messages and questions and can't. This is the first time it's really running. So I would now do the following. I will just do an endless loop so we only see one jump main, push main, jump. Okay, let's just endless loop at the end here. So it will only run for one iteration. Okay, now I compare to my initial iteration and see where I did a boo-boo. What was my thingy? Shit. I need to find Okay, let's check what it did. Okay, that one has 2 neighbors. It should survive. This is an infinite pattern. It won't die. This is the second iteration. Something's already wrong in our... Sick. What? Where is the code? Yeah, you can... The first frame is that one here. We used it all the time. Wait. This is the first frame. So okay, so let me check. Survive didn't work. Like keep didn't work. Then we have spawn did work. This is die. This is correct. This is survive didn't work. Die. Spawn works. What is... spawn works. It looks like spawn is working. Wait. I have an error in the rules. I have an error in the rules. We have a different behavior. I think I oversimplified here a little bit. Yeah, no, I can see that survive doesn't work, so keep doesn't work properly. That is no. We need... Yeah, this is the center. Neighbor center, and then we have a keep which should be like that. Oh wait. What? How it's supposed to run when delete dot just as founded? when delete dot. No, I don't. The target. We have double buffer here. There is no. That's solved. I don't know if you missed that before, but store target, store swap, target, store case, and that's the keep. Pop, swap. Yes, that's what I do. Now minus. Oh, I test the wrong cell here. I decrement 68. That's the issue. Nope. Hype train. Teaser. What? 66 people. That's so cool. Welcome. Hallo. Oh. So cool. I have no clue how hype trains work, but whoop whoop. I have no clue. What do I do? Okay, story from so 2 days ago. 2 days ago, I decided I want. Explain. Yeah. Here we go. 2 days ago, I decided I want an emulator for this device because I'm too lazy to write my code myself. I want the community to be able to write code for that device. So I thought, okay, I can't give the devices to all the people. I should write an emulator. So what I did is I started writing this IDE with an own developed assembly language that's documented on bitluni luniASM with instruction set, and it's able to basically run the code, compile and run the code. You can save a compiled bytecode compiled binary, or you can clipboard the binary to and put it to your clipboard with as an C array. But you can also load binaries. So we have contributions already, but I won't. Oh, I can show a contribution. Let me get on Discord and download that file here, and I hope I don't here Rickroll. That's from Life in Cycling. So, but we run this here, which is Game of Life, not working right now. It's the first frame, and I think I found a bug, and I need to concentrate. And this is what's happening here. Yeah, the emulator already runs, but it is a little bit buggy on the device. Ach so, keine Assembler, keine englische Sprache. Rita, sorry. Wir können ja für einen Moment auf Deutsch sprechen. Also willkommen. Moment, aber Rita, wenn du Assembler kannst, dann brauchst du ja nur das eigentlich zu lesen, dann weißt du sofort, was los ist. Also wie der Assembler funktioniert, er hat überhaupt keine Register, alles wird vom Stack gemacht. Also pusht man alles auf den Stack und dann führt man es aus. So wie FPU. So I was just recapping that the assembler has no registers whatsoever. It just works with the stack. So if you have like a binary operator, you push two values on the stack and they're just popped and the result is pushed on the stack again. Just like the x86 FPU. Oh, yeah, I hope we get like a high level language plugin that generates the assembler from C or Python or whatever. And so we have like an higher level in between thing. Or we do like this graphical. Keine Sätze verstehen Keywords. Yeah. Okay. That's what's happening right now. And this is stack full. You missed the train. How did I miss what do I have to do? Oh no, I don't know how to work. Yeah, better luck next time. Oh shit. Yeah, I don't know how hype train work. Oh, this window is also so overcrowded, the chat window. Oh, nice. Okay, yeah, too few people to. Die CPU ist komplett virtuell. Das läuft alles in der Emulator läuft alles in JavaScript. So it's a complete virtual CPU. It's not existing at all. It's just a virtual one that's running in the browser in JavaScript or in C++ on the device here. Das ist einfach eine virtuelle CPU, die ich dann einfach implementiere, entweder in C++, das läuft dann auf irgendwelchen Prozessoren oder in JavaScript im Browser, damit jeder das gleiche Ergebnis hat. Okay, ja. Gut. Wie der Name sagt, bitluni. Ja. And the biggest surprise is that you can do this basically in 24 hours. You can develop your own language with flaws, but it's still. We are expanding it. Okay, now I need to fix my stuff here. It still didn't survive. I fixed the error with the 86. Wait, where is it? Oh, we load. $68. That's 64. Yeah, that should be the center. What if I pop it? Pop up. Pop and push a 1. Doesn't change anything? What? Oh, that's strange. Then the count is not right. Ja, das nicht, aber ich kann ja praktisch, der Assembler ist ja nur die unterste Stufe, praktisch so wie eine Turing-Maschine. Und wenn ich dann diese virtuelle CPU einfach auf allen Plattformen, egal wo, genauso implementiere, dann läuft es überall gleich und ich kann das, was im Browser andere Leute, die zum Beispiel dieses Gerät nicht haben, wenn die es im Browser implementieren und ich lade es dann hier drauf und läuft im gleichen Emulator, dann wird genau das gleiche rauskommen. Okay, so now it doesn't keep the center. I don't know why. So it should. We have center, target, neighbor count. Then we push load S, so we have neighbor count, center, target, neighbor count. Then we compare with 2 is spawn. That's neighbor count. We have center, target. No, that's wrong. That's wrong here. Okay. All right, I think I found it. That's the error. Push main. Is it main loop? No, main. Okay, peeps. Game of life. World first. Game of life. It's not world first. It's working. What? Oh yeah, nobody wins it. I will check Discord now if anyone won the device. No implementation yet. I was the first. Oh, it died. Why did it die? It died. Why did it die? No, it died. It's broken. Okay, let's try the glider. Init game 2. Huh? Huh? Is there a stack? No. Did I mess up my stack? Oh yeah, that could be actually it. But why do I not see this game here? Store. The glider, I messed up the glider, I think. Where is the glider? No, this is not the glider. Oh, yeah, you're right. Oh, yeah. Z80, you are really good. 48. Let's do 48 here. Then we have 80, 84, 88. Okay, that's also a glider. Yeah, it's gliding. The glider runs. Sweet. Game of life implemented. Now we need to fix our emulator and run it on the device. Well, it's really slow. I hope it doesn't die down there. It died. Bedtime for you? Okay. You know what? Should we just upload it? Yeah, I copy it to the clipboard. I will copy it to the... It usually should wrap around, so I don't know what's happening there. I have to... And that's something for debugging. But I will just upload this code, which is already just clipboarded. Kaspar, brush your teeth, and now let's try one more thing. So let's run the code, upload it to the device, but it won't run. So it's basically, here we go. Yeah, but I just only show the memory should be still like big enough, and I just clip it. It should just move there, but something different is off. Did it write? Yeah, I think it doesn't work. No. Okay, still broken. I will check, debug it, and Plattform übergreifend. I will fix some bugs of the stream, and I will be back tomorrow, and we can test some software maybe just for a short stream to wrap things up. Okay. Thank you everyone for joining it. We have a cool game of life thingy here. Let's run it again. It broke down. Cool game of life thingy. It should just wrap around. It's just wrapped around. It should just start at the top again. So I don't know what's wrong there. But I will find out and I will report tomorrow, but I don't know at what time. No, it doesn't break on the wall. It just reads the pixels from the other side. That's how that should work. Or maybe oh, I might no, yeah, no. I know what the issue is. You know what I did for the scroller? We need the same here. Super, danke Rita. Ja, also nochmal auf Deutsch. Was ich versucht habe beim Game of Life ist, das ist dieses klassische Ding, was sich so fortpflanzt, dass es einfach praktisch über den Rand einfach auf der anderen Seite weitermachen sollte. Aber was jetzt passiert ist, dass er nicht praktisch auf der gleichen Zeile bleibt, sondern in die nächste Zeile geht. Und da beim Game of Life könnte es kaputt gehen. So what's happening right now is I wrap around, but it could be like continuing in the next line, and then Game of Life might break. Okay. Bye bye everyone. Thank you for joining the stream. Auf Wiedersehen. Gute Nacht. Jeder. Ich gehe jetzt gucken. I go Netflix watching Three Body Problem. Bye bye. Should we rate someone? I think let's rate someone. Who is online? Who is online? Yeah. Yeah, we go Timon. Here we go. Timon. You can watch the pigeons. You can watch the pigeons. Oh, 29 viewers. Amazing. Okay. Bye bye everyone. Have a good sleep today.